Alright class, so what we're going to look at today is solving problems with two right triangles. So first off, let's recap. What minimum requirements or measures of a triangle do you need to start solving a problem using the primary trig ratios? So anytime we're given a right triangle and we're given two sides, then we know we can solve for an angle, so specifically the reference angle. Whereas if we're given one angle, a reference angle, and one side, then we can solve for another side. So if you have a right triangle and we're given any of the two sides, we can solve for the angle. If we're only given an angle and one side, then we can solve for a side. So let's go over these two examples where it involves two right triangles, and then we have to solve for an angle or a side. So first example, a searchlight is mounted at the front of a search and rescue helicopter. The pilots flying the helicopter 150 meters above the ground, and the beam is angled at 70 degrees from the horizontal. The beam spreads out at an angle of 5 degrees. How wide an area does the beam illuminate? So here we have a searchlight that's mounted in the front of this helicopter here. So the pilots flying the helicopter 150 meters above the ground. Just draw a diagram. So helicopter is 150 meters above the ground, and the beam is angled at 70 degrees from the horizontal. So from the horizontal, the beam has an angle of 70 degrees from it. Okay, so we have the beam here, which is angled 70 degrees from the horizontal. And this beam will spread out at an angle of 5 degrees. So this beam is going to spread out at 5 degrees. How wide an area does the beam illuminate? So we have to look for how wide is this beam here on the ground? Okay, so I'll say we're looking for X. Can you just highlight it so it's clear that this is the beam? All right. So this is a problem with two right triangles. So let's see where the two right triangles are. So the height here will make a 90-degree angle with the ground. So here we have one right triangle, and then we have another right triangle here. So it's like one right triangle on top of the other. But we have to find out this width between the two right triangles. So the part where they don't overlap with each other. So based on the information given, what we can find first is this is the horizontal, this which is parallel to the ground. So if these lines are parallel, we can use the parallel theorems to figure out the other angles. So let's see, based on the Z pattern, the Z pattern, we see that this angle is also 70 degrees. And then again, based on the Z pattern, we can conclude that this angle is the sum of these two, which is 75 degrees. Okay. So, what can we find from these two right triangles to figure out this width between them? So if I just take a look at this triangle here, if I want to find this side here, it's probably useful to find this side at the bottom here. Okay. And we can do the same thing with the bigger right triangle. We have the angle and we also have the side, so we can probably find this side at the bottom here. So if we know this whole side and this side here, what we can do is subtract those two sides to find x. So if I were to label this triangle, so let's say this is A, B, C for the bigger triangle, and A, B, D for the smaller right triangle. Okay, so we're looking for DC or X. So to figure out X, we'll take the longer side, which is BC, subtract the shorter side, BD. So let's find BC first. So to find BC, we're looking at this bigger right triangle here. So the reference angle, let me just grab another color. Reference angle will be 70. BC, the side that we're trying to find, will be the adjacent. And the side that's given is the opposite. We have the reference angle, the opposite side. We're trying to find the adjacent. So using what we know, SOHCAHTOA, opposite adjacent, we will use the tan ratio. So let's set up the ratio. Tan of the reference angle, 70 degrees, is opposite 150 over adjacent, which is BC. Okay, so the short way is, if the node's at the bottom, we can just switch these two. BC equals to 150 divided by tan 70 degrees, which is 150 divided by 1070. Just round to one decimal place, 54.6. And is this meters? So we found BC. Now we're going to do the same thing with BD. So since we're finding BD, we're looking at this right triangle here. So with this right triangle, 75 degrees is the reference angle. The side that we're trying to find is still the adjacent. The given side is still the opposite, so we will still use tangent ratio. So 75 degrees equals to opposite, which is 150, over adjacent, which is what we're trying to find, BD. Again, unknowns at the bottom. Let's switch those two around. BD equals to 150 divided by 1075 degrees, which would give me 40.2 meters. And now I can find x, so BC, subtract BD, 40.2, and that gives me 14.4 meters. So therefore statement, the beam illuminate width of 14.4 meters. All right, so that's example 1. So with all of these problems that involve two right triangles, we will always need to use information from both triangles to figure out what the problem is asking for. So the second example, a video camera is mounted on the top of a 120-meter tall building. When the camera tilts down, the angle of depression is 36 degrees to the bottom of the building beside it. If it tilts up, the angle of elevation is 47 degrees to the top of the same building. Part A asks how far are the two buildings. Part B asks how tall is the building viewed by the camera. So we know one of the buildings is 100 meters tall. Now, the camera can tilt up and down to the next building. That means the camera has to be on the shorter building. So this building is 120 meters tall. So if the camera tilts down, the angle of depression, so we know from previous day that the angle of depression is the angle between the horizontal and the line going downwards. So in this case, when the camera tilts down, angle of depression is 36 degrees to the bottom of the building beside it. So this angle here will be 36 degrees. If it tilts up, the angle of elevation is 47 degrees to the top of the same building. So angle of elevation, angle between the horizontal and the line going upwards. So this angle here is 47 degrees. And we know this building is 120 meters tall. So part A asks us to find how far apart are the two buildings. So if I just draw this line all the way to the end of the next building, we're assuming that the building is not tilted. So it's going to be making 90 degrees with the horizontal. Okay, so here we have two right triangles. We're finding the distance between the two buildings. So we're looking for this distance here. This building, so shorter building, is 120 meters tall. So this is the same thing as this side here. 120 meters. Okay, so I just label all the information that's given and what we're trying to find. Now, in order to find x, we have more information in this triangle, so we're going to solve using this triangle. Well, do we have enough information to solve? We have the reference angle, a given side, so we can find another side. So this would be the reference angle. The side that we're trying to find is the adjacent. The side that's given is the opposite. So based on the primary trig ratio, opposite adjacent, we'll use tangent. So tan of the reference angle, 36 degrees, equals to opposite, which is 120. Adjacent is what we're trying to find, is x. Unknowns at the bottom, switch them around. X equals to 120 divided by tan, 36 degrees. Which gives us 165.2 meters. So the two buildings are 165.2 meters apart. Okay, so that's for part A. And then part B asks us how tall is the building viewed by the camera. So we have to find the height of this building. We know this is 120. So as long as we can find this side here, we can just add them up to get the total height of the taller building. So we know from part A that this side is 165.2 meters. So now, if we're finding this part, we're going to use this triangle. We do have a reference angle and another side, so we're able to find this side. Added to this side will give the total height of the taller building. So this time, this is the reference angle. We have the adjacent side, 165.2 meters. We're finding, we label this as y, and that will be the opposite side with respect to the reference angle. So again, we're going to use the tangent ratio. So tan of 47 degrees. This time we're finding the opposite side. We do have the adjacent, 165.2. This time the unknown's at the bottom. So to get rid of it, we'll multiply both sides by that number, 165.2. Cancels out. Y will get 177.2. And the total height will be 120 plus 177.2, which would be 297.2 meters. So we can conclude that the taller building is 297.2 meters high. Okay. So in this case, for this question, part A, you only need to use one right triangle, but part B, we need to use the information found in the first part to solve for the unknown side. Okay, and that's all for the lesson today.